We now know that the universe contains vast voids of cold, dark nothingness that no one could have predicted. But let's face it, something is unnerving about the vastness of space. Therefore, it's no surprise that we're more likely to notice the good things. However, in order to truly comprehend the universe, we must gaze into the void. We might find our best explanations of the cosmos in the void. NASA has uncovered an important discovery in its search for cosmic voids, a cavity some millions of light years distant from Earth. What is 330 million light years across, nearly empty, terrifying, and full of answers? Let's find out. If you look up into the night sky on a clear night from anywhere on the planet, you will undoubtedly see the stars. If you live in a remote area, you will be able to see these stars at their most vivid and spread over the sky. Because of this, you're undoubtedly wondering what the void is that is so frequently discussed. Even though it is not readily apparent to the naked eye, scientists using telescopes have known about this emptiness for some time. The emptiness turns out to be a portion of the Milky Way devoid of new or young stars. Astronomers now have to rethink the distribution of stars in galaxies. Our Sun is one of between 100 billion and 400 billion stars that call the Milky Way home. In addition, the Milky Way is approximately 26,000 light-years away from Earth. Scientists use a Cepheid kind of pulsating star to figure out the dispersion of stars. Scientists can determine the redshift and distance to us from Cepheids by measuring their pulsation pattern and comparing it to the brightness of our star. Additionally, from studying Cepheids, astrophysicists have been able to establish the form of our galaxy, which actually is distorted strangely. So far, everything appears to be as it should be. Where then is the void? A 150 light-year radius around the galaxy's core is home to Cepheid stars. 8,000 light-years from the center of the galaxy, there is a large area absolutely free of Cepheids. It's not easy to look for stars, and this is due to the galaxy's abundance of interstellar dust, which can easily obscure stars. The team used near-infrared light to conduct scans to compensate for these shortcomings. That's when they discovered the lack of Cepheids in the area. The current results indicate that there has been no significant star formation in this large region over hundreds of millions of years, says Giuseppe Bono, a project team member. While Bono's assessment of the scans is reasonable, the question of why no stars have formed in this region, and if they have, what happened to them, remains unanswered. That area of space-time has a unique quality about it. This one might theoretically be ruled out, given we don't have substantial enough scientific apparatus to investigate aberrations in space-time. It's possible that if we had more powerful instruments and were looking for distortion specifically, we would have discovered it. On the other hand, our sensors may never be able to detect spatial distortions because they lack the sensitivity to detect them. Some form of dark matter, antimatter, or other strange particle is present. We know our equipment likely wouldn't pick up the unknown, so anything like a blob of dark matter or some antimatter generating process that precludes or cancels out the creation of the Cepheids. Regardless of whether or not we can see it from our backyards, the idea that there is a void in space without any stars is nonetheless disturbing. Of course, a more logical answer is possible, but as of right now, it remains a mystery. As Yvonne Chouinard famously put it, fear of the unknown is the greatest fear of all. As a result of its enormity and the enigmatic aura surrounding it, the unknown has the greatest impact on us. That's not the only mystery scientists are trying to solve when it comes to the night sky. A void, known as the Boots Void, aptly termed the Great Nothing, lies beyond our galaxy. This is because it is a vast spherical region of space with only a few galaxies. It's one of the universe's greatest voids, and it's also consistent with the lambda CDM hypotheses. This is a cosmological hypothesis that talks about the universe's consistency in terms of dark matter, dark energy, and regular matter. Near the constellation Bootes, the northern sky's ploughman is the universe's darkest hole. This region, known as a vacuum, spans 250 million light-years and is nearly devoid of matter. Thousands of other galaxies may be found if a region of the same size was centered on the Milky Way. The Bootes void, on the other hand, only contains 60. As a result, as viewed from the core of the galaxy, the universe appears dark and void. The Bootes emptiness is thought to result from several voids combining into one ultimate void. There is a cylindrical zone in the center of the void in which the other galaxies reside. This would make sense, especially knowing that the other holes were likely their own spherical shapes which had the capability to come together. If galaxies are cities, then the margins of a void are the suburbs, and the center is the darkest wilderness. However, cities and roads alone aren't enough to make up an atlas. The blank places in between are just as important. To complete their map, scientists are progressively venturing into the deep, dark wilderness of the emptiness. And in doing so, they uncover the existence of other, darker forces in our cosmic fabric. About 80% of the matter in our cosmos is dark, and it neither emits nor absorbs light. However, the stars, gas, and dust that make up the visible matter of the universe mirror the underlying distribution of dark matter due to their gravitational pull on atoms. Dark matter is most concentrated in regions where galaxies are thickest. The inverse is also true. Dark matter should be sparse in an area devoid of galaxies, or nearly so. Voids in the dark matter distribution are large, shallow troughs. Galaxies are found amid tall, narrow peaks. A normal galaxy has the same height and footprint as the Empire State Building, and a medium-sized void would be a 3-foot deep hole 3 times the size of Manhattan if you use height as a proxy for density. We can only get a sense of how vast and void these areas are by taking measurements in that crucial third dimension. Voids can also inform scientists about a different kind of darkness known as dark energy. It is responsible for the acceleration of the universe's expansion and the size and quantity of voids. It would be helpful to measure the distribution of void sizes and profile shapes to identify this force. Dark energy's influence on void growth over time would provide us with insight into the strength of the dark energy's effects. So, despite their emptiness, voids hold a lot of potential. The only problem is that the vastness of space makes it difficult to locate an emptiness. Even the massive Bootes void went undetected until Robert Kirshner and colleagues found it in 1981. Even though we're in a 3-dimensional world, we can't perceive depth in the sky because of its enormity. A void is large and mostly empty, but it is hidden from view by galaxies in the foreground and background. Only by using precision devices to measure the third dimension can we comprehend how enormous and empty these regions are. Astronomers have discovered several comparable empty areas using similar methods since the discovery of the Bootes gap. The Milky Way is not just home to a large emptiness, but it is also likely that we are surrounded by one. An area of space known as a local void surrounds the Milky Way galaxy. Our galaxy, on the other hand, tends to gravitate toward denser places. The local void gradually expands as a result of this. Voids can be found everywhere and come in a variety of sizes and shapes. It's not enough for scientists to know that voids exist. They want to know how many there are, how big they are, and how they're distributed in space and time. Scientists are relying on gravity to accomplish this. As predicted by Einstein's general theory of relativity, all kinds of matter and energy exert gravitational forces. which in turn impacts the course of light. According to Clampett, gravitational deflection of light by mass is like the familiar effects of glass lens or prism, but it is far more difficult to perceive. Strong gravitational lensing occurs when matter is dense, resulting in striking multiple distorted pictures of distant objects. A weak lensing occurs when matter is reduced to a very low density, resulting in a subtle twisting of light, amplifying background galaxies and other minute changes that require careful inspection. In order to discover voids, several alternative lensing characteristics might be applied. As a result, voids will play a significant role in the future of astronomy and the cosmos as a whole. The reason for this is that in the far future, the cosmos will be more void than not due to the effects of dark energy. The network of intergalactic space will disintegrate, leaving just specks of light in its wake. Matter, not emptiness, will be the exception billions of years from now. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.